Right, good morning everyone and welcome to our first part of our series of webinars on big data. This morning we're going to be giving you a bit of an introduction into big data, really around understanding big data and what big data is. By way of introduction, let me just give you a bit of insight into who Information Management Group are. As you can see, we were formed in 1999, so we've been around for a while. We've got presence in a number of countries and across the UK as well. We are growing in size and we are information management specialists, and I'll give you a little more insight into a little more detail in what we do in the next couple of slides. We have experience across a number of sectors, and as you can see, we're SAP partners, Oracle partners, and Microsoft partners. So what do? We provide strategies, services, and solutions that enable our customers to access, analyze, and report and share their data. We help them manage their business more intelligently with a view of improving performance. A little more about us. We're a winner of a number of awards, and again, as we said, Microsoft, SAP, and Oracle partners. Quite important for us, we are the only UK preferred supplier on the Microsoft SQL Server customer advisory team, which gives us quite a good path to the software vendors. We're also the only Microsoft Parallel Data Warehouse implementation partner in the UK. And I think very important for us and for our customers is that we're the only UK independent company in recent Gartner survey of the top information management solution providers. Okay, here's a bit of an overview of what we do. Really services across a number of areas, our advisory services, solution delivery, and application management, and you can see a little more detail in each of those areas. And across all of those, we also provide project and program management services to ensure the success of your projects and programs. Okay, I think enough about that. Let's move on to the topic at hand, and that's understanding big data. Really what we want to achieve today is give people an insight into what big data is and also how big data differs from the types of data that you might be used to dealing with, or the types of data that you do build solutions on or use on a daily basis. So from a definition point of view, there's quite a lot out there, and we put together a few bits and come up with a definition that we think encompasses what big data really is. And it's really data that is extremely large. It's difficult to work with. It's beyond the capability of the commonly used tools that we have today, or that we typically use, that we have deployed in the enterprise, especially when we consider that we need to process this data within a reasonable time. And we also see the data's growth as exponential rather than organic, and this is very important, and you'll see some of the examples that we cite a little bit later on. Again, you may ask, how is this different from perhaps big data warehousing or other large data sets? And we've summarized it down, or generally the industry summarizes it down to three key things, and that's the variety of data. So the different types of data that you deal with, both in terms of content and in terms of where the data comes from. Again, we're going to highlight some good examples later on, and I think that will really contextualize what we're talking about. The volume of data, and again, it's all contextual, and you'll see some really large amounts of data that we talk about and some that aren't so large, but again, do have the attributes that we are talking about here. And then velocity of the data, the speed of the data both in and out. So, you know, it's one of the challenges is getting data into the enterprise, but also the other challenge is processing it and getting it out. So we see variety, volume, and velocity as being the contributors to really saying why big data is different from big data warehouses or other bits of data that are large and just in size by themselves. Okay, so I'd like to put things in perspective when we say, you know, what is big? You know, what is big for one enterprise might not be big for another. So a few key points here is really the amount of data that gets created daily, and the figure that's cited is 1 quintillion bytes of data. So just to put that in perspective, you can see here at the top 1 quintillion bytes in data, And I think the unit of measure that we're most comfortable in dealing with probably is terabytes at the moment. So we're essentially looking at just under 1 million terabytes of data created on a daily basis. Of course, there are some units of measure above that, and you'll see those coming into the realm of the discussion as big data grows. An interesting fact is that 90% of the data around today has been created in the last 2 years. Again, that just alludes to the exponential growth of data. And the volume of data doubles, sorry, that should be every 2 years, not every 2 months, every 2 years, roughly in parallel to Moore's law, which states that the processing power doubles every 18 months or so. So you can see as our processing power and storage increases, so does the data that utilizes that. Okay, so where does big data come from? We've listed out a few sources here. I think we used to the the typical sources of data, such as line of business systems and customers and that sort of thing. But here we've listed out some more examples like mobile phones. An interesting fact is the amount of mobile phones in the world today essentially means if each phone had an IP address, we would run out of IP addresses were it not for IP version 6. And these are just mobile phones, sensor technology, not only things like biometrics, but also weather sensors, tectonic sensors, and oceanographic sensors, which play a large part in our world. We've got RFID or radio frequency ID. Again, a high volume of transactions, lots of items that are being tracked through radio frequency and the data that comes from this. Software logs, things like your application system and crash reports or exception reports, as they prefer to call them. Generation stuff that's generated telling us how users are using our software. Astronomy, we've got a good example on the next slide to give you a little more insight into that. I think social networks are something we're all very familiar with, and we're going to look at those in a little more detail. Photo and video, of course, there's loads of digitization around and a lot of social network relating to photo and video, things like Instagram and 500px. Then more traditional sources of data, large-scale e-commerce systems or vendors such as eBay and Amazon. And email, I think everyone's familiar with this one. You probably see a lot of email in your inboxes on a daily basis. Then there's unstructured data, loads of Word documents, PDF files, things like blog comments, things that really don't fit into any structured format. Corporate internets, which are repositories for knowledge management, loads of data that exists within the organization. And then instant messaging. Imagine all of our conversations recorded on instant messaging. In fact, Google and Link do that already, although there are options to switch that off. But you can just imagine the data that's generated from that. Okay, looking at some specific examples of big data, the first one we'd like to look at is the Sloan Digital Sky Survey, and this is essentially a project that is in the process of mapping the universe, and you can imagine the amount of data that they're collecting via the visual spectrum and also on the radio telescopes. It's to the region of 200 gigabytes per night, and the repository currently is 140 terabytes in size. A lot of this data is available on the internet for people to go and consume and use. But again, you can start understanding some of the challenges around how would we use this big data. We spoke about mobile subscribers in the previous slide. So currently there's 4.6 billion mobile subscribers on the planet. That's almost one mobile phone or one SIM card per person, and that can only be seen to grow in the near future. More traditional sources, we've used Walmart here, for instance, which currently processes in the region of about 1 million transactions per hour. And I think it's important that we have this as an example because it doesn't necessarily seem large. It's probably a reasonable amount of transactions, certainly less than the amount of transactions that a mobile telephone network would produce. But it's the consistency they come through at and the richness of the data that is contained in that. Back onto science again and the Large Hadron Collider. This is probably the best example of what is really, really big, and we're talking about 13,000 terabytes of data generated in a single year, and that was during 2010, and I can imagine that this will increase as the sort of experimentation with the LHC does proceed. There's currently 1 to 2 billion people that are connected to the internet in the world today, and you can just imagine the number of transactions, the number of page hits, the amount of data that's exchanged, the amount of data that's browsed by these amounts of people. Obviously not all of it is stored, but it is generated. And then Facebook. Currently Facebook contains something in the region of 40 billion photographs. Again, no small amount of data to deal with. And I hope by citing these examples that we've illustrated the kind of mix between variety, volume, and velocity of different types of data that we see making up big data. To extrapolate the social network example again, here is a snapshot of really what happens on the social scene, social media, in 60 minutes. And you can just see the amount of interactions that are generated with YouTube currently being the highest, within the region of 2 million videos viewed every hour. I think these numbers are also increasing. Okay, so who is creating this data? Important to note, maybe not so important, that the largest portion is created by management. But let's not say any more about this. I think the key areas that we want to highlight is the amount of data created by customers and the amount of public data that's available. So firstly, let's talk about data that's created by customers. A good example again is the software kind of logs, or perhaps the crash or exception logs that we spoke of earlier. Think about how we could use this information to make software better, or how we can better understand how customers use our software. If we take a look at the mobile telco world, for instance, there's a number of vendors available that offer services that will either, of course with the subscriber's permission, install software on the mobile handset or on the SIM card for less advanced handsets or non-smartphones. And this software allows the mobile networks to track certain indicators like call drop rates, the quality of calls, and a number of other indicators. And this is really a great way for telcos to measure customer experience at the point of delivery. So just by use of these two examples, you can imagine the gems of data that lie hidden in this customer data. Then public data at around 17% of the total. We keep talking about social networks, but imagine the richness of the data, the richness that lies in this data. What's important, of course, is that we need to understand the signal-to-noise ratio, because there's probably a lot of non-relevant or data that's not useful to us. And we need to be able to extract some valuable insights from this data. And I think there are some out there. There was an article in, I think it was a Forbes magazine yesterday, where a UK-based company called DataSift has concluded an agreement with Twitter to acquire 2 years' worth of archived tweets that they'll be using for data mining, with a view of drawing some insight from that, and obviously looking at things like product trends and that sort of thing. Okay, so we've spoken in theory quite a bit. Let's look at perhaps some of the practical applications of what big data might be used for, or the show me the money question. I think internet search is probably something that we're used to dealing with on a daily basis. It's something we use often. It's something that's known to us. It's not a new technology. It's improving all the time, but it's really prevalent, and it's something that we do touch every day, or touches us every day. Some of the I suppose more common uses, but not necessarily in everyday business, are the uses around things like meteorology, genomics, or connectomics. Connectomics is the processing of neural images and neural connections, obviously within the brain, and you can imagine the amount of data from this. But I think from an everyday example, things like marketing, the sample that we used, or the example we used around extracting value from the Twitter feeds. Things like predictive analytics. Imagine being able to predict which of your customers were going to be leaving you in the near future, and using that information to try and retain them, or just to increase customer acquisition. And then personalization as well. I think we're used to personalization when we use things like Google, things like YouTube, and we're often surprised at the result. How do they know that's what I was looking for? And I think, you know, that is developing on a daily basis and getting more and more accurate. And these are really practical ways that we can use this information. Things like GPS monitoring. I've listed tracker and LoJack, for instance, as examples here, where vehicles are monitored either using a GPS system or perhaps land-based systems like a mobile network and triangulation. There's an immense amount of data collected. Using these, you know, we can recover tracked vehicles. They're good for managing fleets. And also things like insurance. Imagine in the future where insurance companies might be able to more accurately understand how vehicles are used by their customers. You know, it opens up the opportunities in terms of, you know, insurance fraud or reducing insurance fraud, or perhaps, you know, getting more accurate costs, you know, for insurance. Then some of the more traditional ways, I think, things that we used to hearing, things like credit risk scoring and analysis, behavioral scoring. I'd imagine there's a large amount of data out there on the social networks that could indicate some kind of behavioral statistics that would help us understand our customers better or potential customers better. And yeah, things like abnormal trading pattern analysis. I think we've seen a lot of stuff in the press and experienced the negative downside to what's happening in some of the markets, and certainly the amount of data out there should help us highlight these abnormal trading patterns and take action before it's too late. And these should really be supplementing or improving the models that we have today. Okay, of course, with these opportunities come challenges, and what are some of the challenges in dealing with these amounts of data or with big data? Firstly, how do we capture the data? We've spoken about loads of new sources, but how do we really get hold of this data, and how do we get this data into the organization? So again, the example of DataSift acquiring these tweets from Twitter, there's going to be, I'd imagine, an amount of mechanics that need to happen for them to get hold of this data. And what about data that we know exists, or data that we think would be useful to the enterprise, but we don't know how to get hold or capture this data? So the data that is sitting out there that hasn't been entered into a web-based form or captured in a Word document somewhere. These are challenges that we need to deal with. Then how do we store this data? Storage has become incredibly cheap, again, along with Moore's law, where performance, you know, doubles every 18 months or the costs halve. It is becoming cheaper, but still, when we look at SAN-based storage today, it can cost anything between 13 and 53 pounds per terabyte, depending on the way you implement your SAN storage. And with volumes that we've mentioned, you just need to extrapolate that figure to really understand that costs might be prohibitive just from starting a project like this, and never mind incremental costs as the data grows. And this will really affect any kind of return on investment that you may have to justify to undertake projects like this. Then how do we search this data? We need to understand, obviously, that not every organization is a Google, and I think just the frustrations that you probably deal with on a daily basis when trying to find documents on your local computer, or, you know, documents or emails in your inbox or your stored folders, it becomes even a greater challenge within the organization, which has a limited amount of data. Now extrapolate this beyond the organization to the sources of big data that we're talking, and you can imagine the kind of challenges that we face, and how the current tools that we have might not necessarily help us searching this data. How do we analyze the data? How do we visualize the data? Again, this data is significantly different from the data that we're used to dealing with on a daily basis. The current tool sets are not necessarily going to be the best to help solve this problem, both in terms of analysis and visualization. So there's some solutions that need to be found in this area. This leads us on to the next point, is how do we move beyond relational databases? So I think relational databases have been our frame of reference for a very, very long time, and they are still very prevalent in the organization today in terms of line of business systems, e-commerce, even things like content management, things like SharePoint databases are all relational in nature. And how do we move our paradigms around this, and how do we understand what comes beyond the relational database and how these can solve our problems or open up our opportunities around big data? Then the last point here is how do we integrate big data solutions into our architecture, or how do we leverage our existing investment in our architecture? Organizations have spent a lot of money on their software solutions and the additional services and licensing and annual maintenance. What we don't want to go and do is throw away this investment that we have to date. We really want a way that we can integrate big data solutions into our existing architecture, extend our existing architecture, and really realize and leverage our existing investments, and at the same time, I suppose, make it easy to use these new technologies. So in the ways that we are familiar with interacting with our current technologies and architectures, we'd like to extend this to include big data and make big data easy to interact with too. So how are these challenges going to get solved? We've listed out a few examples of the things that are starting to come to the fore. You've probably heard about a lot of this already. That's been spoken about in the press, that's been spoken about by vendors specifically. Things like parallel databases and servers, and again, this is where the benefit of scalability comes in. You're talking about tens of servers, hundreds or even thousands of servers. Things like database appliances. You will have heard Microsoft speaking about the parallel data warehouse, SAP speaking about HANA, vendors like NetEase and Greenplum all coming up and saying this is the next solution, database appliances, and this is how you're going to handle your big data. Things like data mining grids, ways of just really finding value in these large amounts of data. Things like distributed file systems. You will have no doubt seen lots of discussion around Hadoop. Vendors are talking about cloud computing, things like Microsoft Azure or Amazon EC2, both from a processing and storage point of view. These are solutions that are starting to become more and more popular. Something that we need to consider as well is new data architectures, things like column-based data, again, just moving away from our frame of reference when we talk about relational databases and understanding different ways that we can store this data and different ways that we can model this data. Things like in-memory databases. One that immediately springs to mind is IBM TM1, which is very, very, very performant, but probably not as scalable in the sense that we need it to be to handle big data. So, with that comes the hardware challenges and the costs associated, and, again, your price versus performance kind of trade-off that you always have to deal with. And then moving into the realm of new languages and new syntaxes, something you will no doubt have read about as well is something called NoSQL, which is exactly what SQL isn't. It's uses a query language, but it has things like no fixed schemas and no joins. So again, moving the paradigm in terms of things that we're used to dealing with on a day-to-day basis. The next question is this all hype or is it reality? And I think there's an element of people being suspicious in terms of thinking that it's a lot of hype because there's a lot of talk about it, but we're not really necessarily seen any real world implementations quite yet, or things that are easily accessible to smaller organizations. But our feeling is that it certainly is real, and when we look at the numbers, the large vendors like Oracle, IBM, Microsoft, SAP have already spent more than $15 billion on acquiring specialist big data companies, and they are working on incorporating these technologies into their existing architectures, and these are the kind of things that are going to become available to us almost on a commodity basis, I would imagine, in the near future. There's an estimation that the industry is currently worth $100 million. and that it's growing at 10% per annum. But obviously this is really set to expand. If you look at the Gartner figures that are predicting 650% growth over the next 5 years, this is substantial, and the vendors are taking it seriously. Extending our example earlier of the amount of mobile devices out there, if we extend that beyond just the mobile device sphere, you might be talking smart devices in your home and other devices. By 2015, there's an estimate that there'll be over 200 billion devices in the world, and you can imagine the amount of data that is going to be generated from these devices on a daily and hourly basis. And then by 2020, the estimation is that there will be, on a daily basis, 275 exabytes of data transferred using the internet, and that translates to 288 million terabytes of data. So you can just imagine 288 million of one of your desktop USB drives of data transferred on a daily basis, and this is truly substantial and truly large. So the next question is, do we really need to pay attention to this? What's in it for us as organizations? What's in it for us as organization, information consumers, and what's in it for us as managers, and what's in it for us as information workers? Is big data a symptom? Like we said, hype, or is it reality? But we think, based on the last few slides, that it really is the reality, and it's stuff we need to start paying attention to. Although, we need to unlock the value in this data, and we need new tools that will make this possible. Again, though, it's important to note that software is not a silver bullet solution, and we need the accompanying, strategy, process, and people to go along with that to make this a reality. Which begs the next question: is being realistic about it. Don't we already have enough data? And given more data, can we ask any better questions of the data that we have? Or can we even ask any questions that we don't ask now? You only need to think about how many organizations currently have more than enough data but can't even act on it. So, we need to be realistic about having this big data. If all we have is a hammer, every problem becomes a nail, and we really need to make sure that we don't have a solution, looking for a problem. We really need to identify the business opportunity first. So it needs to be driven by a business need, and we need to understand that technology is an enabler, and we need to be sure that we select a vendor that delivers a solution and not just a piece of software. So where should we start on our journey of moving to big data? Firstly, we need to understand, again, we've listed some really large numbers in this presentation and some not so large ones. So everyone needs to just take a step back and understand what big means for their organization, to put things in context. And we need to understand if we really can unlock the business value in this data. So it's important that we look carefully, looking at your current information management strategy, whether or not you're going to do anything about big data. It's probably important that you do consider this, and if you aren't going to do anything, at least know the reasons why you're not going to do anything. If you are going to do something about it, think about how this is going to form part of your larger information management strategy and where it's going to lead you in the future. Then moving forward, again, how do you leverage your existing investment in tools and technologies and architecture by making sure that you can integrate big data solutions into what you already have rather than starting again. So I'll leave you with those questions, and thank you very much for joining our 30 minutes webinar today. My contact details are up on the screen here, and I'll leave these up for a few minutes. So please, if you do have any questions or would like a copy of the presentation, please, give our office a ring or drop me a mail directly on my address listed below. And we hope to see you back next week at the same time for part 2 of our Big Data webinar series. Thanks very much again for your attendance.